In 2024, a Chinese spacecraft touched down on a place no machine had ever landed before. Not the near side of the moon we all grew up staring at, but the far side. The mysterious hidden face that never turns toward Earth, ever, in the moon's entire history. The mission was called Chang'e 6, named after China's ancient goddess of the moon.
Its goal sounded simple: scoop up rocks and bring them home to Earth.
But what it actually revealed would shake up decades of lunar science. And it would quietly reset the terms of a new space race with America. This is the story of what China's moon mission really found up there. And why it matters far more than most Americans realize right now. Let's start with the landing itself, because it was genuinely unprecedented.
Chang'e 6 launched from Hainan Island in May 2024, riding a Long March rocket.
It aimed for one of the most extreme places in the entire solar system. The South Pole Aitken Basin, the moon's largest and deepest impact crater. This basin stretches across roughly 1/4 of the moon's entire surface.
Scientists believe an ancient asteroid smashed into the moon here 4 billion years ago.
That impact was so violent, it may have reshaped the moon's interior forever. On June 1st, the lander touched down inside the basin's Apollo crater.
A robotic scoop and a drill began gathering soil and buried rock.
Engineers designed the scoop so its digging left a mark shaped like a Chinese character. That symbol, Zong, is the first character in China's own name for itself. The image went viral across Chinese social media almost instantly.
In just days, the ascender lifted nearly 2 kilograms of samples into lunar orbit.
It docked with the orbiter, transferring precious cargo for the long trip home.
On June 25th, a capsule streaked back through Earth's atmosphere. It parachuted down into Inner Mongolia, carrying humanity's first far-side lunar samples.
No nation, not even the United States, had ever pulled off that feat.
Apollo astronauts brought home rocks decades ago, but only from the near side.
The far side had remained completely unsampled, a genuine blind spot in science. That gap existed simply because the moon's far side never faces our planet. The moon rotates and orbits in perfect sync, always hiding one face from us. So for the first time, scientists finally had physical material from the hidden hemisphere. And in July 2025, Chinese researchers began revealing what those rocks contained. 4 separate studies landed as cover articles in the journal Nature. That is science's biggest stage, and China had 4 cover stories at once. The first bombshell, precise proof that the giant basin formed 4.25 billion years ago. That gives scientists their most accurate anchor point yet for early solar system history. The second finding concerned volcanoes, and it upended a long-held assumption. Researchers identified 2 separate volcanic eruptions,
one 4.2 billion years ago. The second wave of eruptions happened a full 2.8 billion years ago. Together, that means volcanic activity on the far side lasted 1.4 billion years. That is far longer than scientists previously believed possible for that region. The third discovery involved the moon's ancient magnetic field, hidden deep underground. For the first time, researchers measured paleomagnetic data from the far side directly. They found the magnetic field appeared to rebound around 2.8 billion years ago. That suggests the moon's internal dynamo didn't fade steadily, but fluctuated instead. It's a detail that forces scientists to rethink how the moon's core behaved. The fourth study examined the chemistry hidden inside that actual mantle material itself. It revealed water content and geochemical clues about the moon's deep interior.
One British scientist called the results turning many established theories upside down.
That's not China's own spin, that's an outside Western scientist reacting to the data. Why does any of this matter to someone watching from the United States? Because the moon's near and far sides look strikingly, puzzlingly different. The near side is covered in dark volcanic plains, easily visible from Earth. The far side is rougher, more cratered, and far less covered in lava.
Scientists have debated why for decades, without solid physical evidence to settle it.
Chang'e 6's samples finally gave researchers a direct, physical way to test theories.
Some scientists think a giant ancient impact reshaped the moon's deep chemistry.
Others connect that history to Theia, the hypothesized planet that helped form the moon. About 4.5 billion years ago, a young Earth suffered a giant collision. That crash may have scattered debris that eventually became our moon. Understanding the moon's far side helps scientists reconstruct that violent creation story. It's not just moon history, it's a window into Earth's earliest days too. Chang'e 6 also carried a surprising bonus discovery nobody had specifically planned for.
Researchers spotted rare meteorite fragments embedded right inside the returned lunar samples.
These fragments came from impactors that struck the moon from somewhere else entirely. Studying them offers new clues about what kinds of objects orbit near the moon. Before Chang'e 6, this kind of far-side impactor evidence simply didn't exist.
Every discovery here builds a more complete timeline of solar system violence. And each new paper keeps landing in the world's top scientific journals.
This wasn't a one-off either. China had already sampled the near side too.
Chang'e 5, launched in 2020, brought back near-side rocks 4 years earlier.
Those samples showed volcanic activity as recent as 2 billion years ago.
That discovery alone extended the moon's known volcanic timeline by 1 billion years. So Chang'e 6 wasn't China's first lunar surprise. It was their second major one.
2 missions, 2 return capsules, 2 sets of textbook rewriting results.
No other country has managed a single lunar sample return since the 1970s.
The Soviet Union's Luna missions were the last before China's modern program began.
That's roughly 50 years where lunar sample science essentially sat still.
China quietly picked that thread back up and has now pulled twice. And they're not stopping with sample return missions either. Bigger plans are coming. China's next mission, Chang'e 7, is aimed at the Moon's South Pole region. It's expected to launch later in 2026, hunting for signs of water ice. Water ice at the lunar South Pole could support future human outposts there. Chang'e 8 follows in 2028, testing how to actually use lunar resources on site. That includes experiments in using lunar soil for basic construction, even 3D printing.
These missions are building blocks towards something much bigger than robotic exploration. China wants to build a permanent human research station at the lunar South Pole.
It's called the International Lunar Research Station, and construction is planned from 2031. China is developing it together with Russia's space agency, Roscosmos.
Other partner nations have joined too, including South Africa, Belarus, and Pakistan.
It stands as a direct alternative to America's own coalition, the Artemis Accords.
And behind all of it sits an even bigger, more dramatic goal.
China says it wants to land astronauts on the Moon by the year 2030. Their plan uses a cruise ship called Mengzhao and a lander called Lanyue.
2 Long March 10 rockets would launch each piece into orbit separately.
The spacecraft would meet up in lunar orbit before astronauts head to the surface. China has already tested the Lanyue lander in simulated low-gravity conditions.
That's a milestone the United States, frankly, has not yet matched.
Meanwhile, American companies SpaceX and Blue Origin are still finishing their own landers.
Those landers are essential pieces NASA still needs for its Artemis missions.
NASA's Artemis II sent 4 astronauts on a test flight around the Moon.
That mission flew successfully earlier this year, a genuine milestone for America.
But an actual crewed landing has been pushed further down NASA's own calendar.
The White House has pressed for a landing by 2028, ahead of China.
Yet several space policy experts openly doubt that 2028 timeline is realistic. One former NASA administrator bluntly told Congress that mediocrity would be an improvement.
That's an American official criticizing his own country's pace, not a rival's.
China, meanwhile, insists it isn't racing anyone, just following its own long plan. But experts note China has been remarkably disciplined about hitting self-set deadlines. Officials there have publicly promised a landing by 2030. No hedging, no vagueness.
One senior Chinese space designer said, reaching the Moon by then is not a problem. That kind of confidence make Western analysts pay very close attention.
Because whoever lands and stays first may shape what comes next up there. Analysts warn, this isn't only about flags and footprints and national pride. It's about who sets the technical standards for future lunar operations. Whoever runs a lasting moon base could define data formats, protocols, even language.
One American analyst asked pointedly, "What if the moon's working language becomes Chinese? If Chinese missions fly constantly and American missions fly rarely, that shapes everything."
This is why China's scientific results matter well beyond the lab itself.
Real nature-published discoveries build credibility, funding, and momentum for the next big step. Every rock sample analyzed successfully strengthens the case for landing humans there too. And China's approach ties its science program directly to its human spaceflight program.
In 2026, Chinese officials formally merged robotic moon missions with crewed spaceflight plans.
They're testing hardware on their Tiangong space station that will support moon landings. Recent cargo missions there tested fuel systems and materials meant for lunar landers. Every experiment on that station quietly serves the larger 2030 lunar landing goal. It's a patient, incremental strategy, building one proven piece at a time.
Some experts describe it as slow and steady, but rarely delayed or abandoned.
America's program, by contrast, has faced years of redesigns and schedule slips. Multiple lunar landing dates have shifted since the Artemis program was first announced. Analysts note China could even move its own landing date earlier if needed. They point to China moving up a Mars sample return mission by 2 years. If China can accelerate one deep space mission, it might accelerate this one too. None of this means American space science is somehow falling behind scientifically. NASA and its partners still lead in many areas of space exploration entirely. But the symbolism of who next walks on the moon carries real weight. The original space race in the 1960s reshaped American identity for generations. A second moon landing, decades later, could reshape global perception all over again.
That's why Chang'e 6's quiet scientific papers matter more than headlines suggest.
They're proof China's space program can deliver real, peer-reviewed breakthroughs, not just promises. And breakthroughs build public trust, funding, and political will for even bigger missions. For American viewers, the takeaway isn't panic. It's clear-eyed awareness. Two major powers are now independently rewriting what we know about our moon.
That's actually good news for science, even if the politics feel tense.
More sample data from 2 different lunar hemispheres means better answers for everyone. We now understand lunar volcanism, magnetism, and impact history more clearly than ever. We understand it because 2 very different national space programs kept pushing forward. The moon, it turns out, still has enormous secrets left to give up. Chang'e 6 proved the far side isn't just some unreachable, hidden wasteland. It's a scientific treasure chest that had simply never been physically opened before.
China opened it first, and the data is already reshaping textbooks worldwide. The next chapter includes ice hunting, resource testing, and eventually human footprints. Whether Americans arrive at the South Pole first is still genuinely undecided. What's certain is that the moon is no longer a quiet, forgotten rock. It's becoming a contested, fascinating frontier again, for the first time in decades. And this time, the science is arriving faster than most people expected. China's moon mission revealed ancient volcanoes, a wobbling magnetic field, and lost history. It also revealed something else. A serious, patient competitor chasing the same horizon. For the United States, that's not just a challenge, it's also a wake-up call. The next few years may decide who truly leads humanity's return to the moon.